ScyllaDB versus Apache Cassandra, understanding the next generation of NoSQL databases. ScyllaDB is a high-performance C++ rewrite that delivers 10 times faster performance with low latency. Apache Cassandra is the battle-tested Java foundation that's proven at scale. The key question is, when should you migrate from Cassandra to ScyllaDB, and what performance gains can you expect? Let's look at the key architectural differences between these two databases. Cassandra is written in Java and runs on the JVM, while ScyllaDB is written in C++ with native execution. Cassandra uses a thread per core model with shared memory, whereas ScyllaDB uses a shared nothing architecture with shard per core design. One of the biggest differences is garbage collection. Cassandra suffers from JVM garbage collection pauses that can range from 100 milliseconds to over a second. ScyllaDB has no garbage collection, providing deterministic memory management. CPU utilization is dramatically different. Cassandra achieves only 50 to 60% efficiency, while ScyllaDB runs at over 90% efficiency, getting much closer to the metal. Cassandra uses heap-based memory management with garbage collection overhead. ScyllaDB uses direct memory access with custom allocators. For I/O, Cassandra relies on traditional blocking I/O, while ScyllaDB leverages modern asynchronous I/O with I/O_urine. ScyllaDB's shared nothing architecture means each CPU core operates independently with its own memory and task queue, eliminating lock contention and context switching that plague traditional threaded systems. Why is ScyllaDB 10 times faster? Let's break it down. First, the shared nothing architecture. Each CPU core is a separate shard with no cross-core locking or synchronization. Data is partitioned across shards, and there's zero context switching overhead. Second, zero garbage collection. With no garbage collection pauses, you get predictable latency. The 99th percentile latency is under 1 millisecond compared to 10 to 100 milliseconds with Cassandra. Memory is reclaimed immediately, giving you deterministic performance. Third, modern I/O with I/O_urine. ScyllaDB uses asynchronous disk operations, zero copy data transfers, and efficient syscall batching. This delivers 50 to 100% better I/O throughput. Fourth, CPU cache optimization. ScyllaDB's data structures are cache line aligned. It utilizes SIMD instructions, minimizes cache misses, and improves branch prediction. The performance metrics speak for themselves. ScyllaDB delivers 10 times throughput improvement on the same hardware. You get a 90% reduction in latency, with P99 latency dropping dramatically. And you achieve 80% cost savings by needing fewer servers for the same load. When should you choose ScyllaDB versus Cassandra? Choose ScyllaDB when ultra-low latency is required for real-time applications, gaming, or financial trading. When you need high throughput of millions of operations per second. When cost optimization is critical and you need to reduce infrastructure by 5 to 10 times. When predictable performance matters and you have no tolerance for garbage collection pauses. For time series data like IoT, metrics, and monitoring with heavy write loads. And for global scale applications like streaming platforms, social media, and e-commerce. Consider staying with Cassandra when you have existing Cassandra expertise and your team is familiar with operations. For moderate workloads where you don't need extreme performance. When you have extensive ecosystem needs with heavy reliance on Cassandra-specific tools. If you have the budget to over-provision servers. Or in risk-averse environments where you prefer longer established technology. The good news? ScyllaDB is API compatible with Cassandra, meaning applications can migrate with minimal code changes. You can even run a mixed cluster during migration. Let's look at a real-world example, Hotstar, now known as Disney Plus Hotstar. The challenge was massive. Hotstar needed to handle enormous concurrent viewership during cricket matches, especially the Indian Premier League, with millions of users streaming simultaneously. The numbers are staggering. They achieved over 25.3 million concurrent viewers, setting a world record. During IPL 2019, they served 10.3 billion video views. They have over 400 million monthly active users. And at peak times, they handle 1.5 million logins per minute. Their architecture requirements were demanding. They needed user profile storage with real-time access to watch history, preferences, and subscriptions. Session management to handle millions of concurrent authenticated sessions. A recommendation engine for fast retrieval of personalized content suggestions. Analytics data for real-time viewership metrics and engagement tracking. And it all had to be geo-distributed for low-latency access across India and global markets. Why did ScyllaDB win? Hotstar chose ScyllaDB to handle their massive scale with predictable low latency. During peak IPL matches, ScyllaDB delivered sub-millisecond P99 latencies while handling millions of concurrent requests, all while using 80% fewer servers than an equivalent Cassandra deployment would require. Let's dive into Hotstar's ScyllaDB implementation. Their system architecture starts with a load balancer and CDN layer, distributing traffic across multiple API gateways that handle their microservices. These gateways connect to their ScyllaDB cluster, which uses per-core sharding with no locks, maintains 99.9% uptime, and delivers less than 1 millisecond P99 latency. They also use Redis for caching. The data models they use include user profiles partitioned by user ID, watch history using wide rows with TTL-based expiration, session tokens as time series data, content metadata and recommendations, and real-time analytics counters. For performance optimizations, they use time window compaction strategy. Read-ahead optimization is enabled. Workload prioritization is configured. They have multi-data center replication across 3 regions. And the system is tuned for 80% reads and 20% writes. The results are impressive. They achieve peak throughput of over 5 million operations per second. Their cluster runs on just 20 nodes, compared to the 100+ nodes that would be required with Cassandra. This translates to an 80% reduction in infrastructure costs. Let's look at real performance numbers. This test scenario simulates an e-commerce product catalog, similar to Hotstar's workload, with 100 million records, 80% reads and 20% writes, running on 16 core servers. Without CDC, Cassandra 4 delivers 500,000 operations per second with P99 read latency of 15 to 50 milliseconds and P99 write latency of 20 to 100 milliseconds. CPU utilization sits at 50 to 60%, and you'd need 100 nodes. With ScyllaDB 5, you get 5 million operations per second. That's a 10x improvement. P99 read latency drops to 0.5 to 2 milliseconds. That's a 20x improvement. P99 write latency is just 1 to 3 milliseconds, a 30x improvement. CPU utilization reaches 85 to 95%, 40% better. And you only need 20 nodes, 80% fewer servers. The killer feature? Cassandra has garbage collection pause times ranging from 100 milliseconds to 2 seconds. ScyllaDB has 0 milliseconds because there's no garbage collection at all. No pauses. From a cost perspective, for 1 million operations per second sustained throughput, Cassandra costs around $50,000 per month, while ScyllaDB costs around $10,000 per month. That's an annual savings of $480,000. Operationally, you get a 90% reduction in ops alerts, 0 garbage collection tuning required, compactions run 5 to 10 times faster, auto-tuning capabilities, and better monitoring dashboards. Let's wrap up with the key takeaways. ScyllaDB's advantages are clear. You get 10 times throughput on the same hardware. Sub-millisecond P99 latency. No garbage collection pauses means predictable performance. 80% infrastructure cost reduction. It's Cassandra compatible, making migration easy. And you get better CPU and memory utilization. When should you migrate? When you're hitting Cassandra performance limits. When garbage collection pauses are causing issues. When you need to reduce infrastructure costs. When you're scaling beyond 100 nodes. When you have real-time latency requirements. Or when you're running high-throughput workloads. The Hotstar success story proves it works at scale. By migrating to ScyllaDB, Hotstar successfully handled 25.3 million concurrent viewers during IPL matches with sub-millisecond latencies, using just 20 nodes instead of the 100+ that would be required with Cassandra. They saved millions in infrastructure costs while delivering a better user experience. They set a world record with 25.3 million concurrent streams. Ready to explore ScyllaDB? Start with the official documentation at docs.scilla.com and check out Hotstar's case study for detailed architectural insights into building ultra-high-scale streaming platforms. Thank you for watching. To join the PingCrowds community for interesting learnings, check out their presence on YouTube and visit the PingCrowds official website.